We've got our mystery. Now, let's open up our toolkit and look at our primary weapon, the chi-square test. And just like any precision tool, there are some rules you've got to follow to use it right.
All right, don't let the symbols freak you out. This is the engine that drives our whole investigation. That little O just stands for your observed data, what you actually counted. The E is your expected data, what your theory predicted you'd count. So for each category, you just find the difference, square it, divide by the expected number, and then add them all up. The bigger the final number, the bigger the gap between reality and your theory. It's that simple.
Now, before we go any further, we have to do a quick equipment check. There are two non-negotiable rules for the chi-square test. First, your data has to come from a random sample. No cherry picking. Second, the expected count for every single category has to be at least 5. This is super important for the math to be reliable. If you have a category with less than 5, you might need to combine it with another one. Always check these two things before you start. Okay, rules covered. Let's get our hands dirty and open up our first case file. We've got a car company, and they have a very specific theory about the colors their customers prefer.
So, the company thinks they've got it all figured out. They have these exact percentages for what colors people will buy. To see if they're right, we've grabbed a random sample of 140 recent orders. Our job is to figure out if the real-world data from those 140 customers actually supports the company's claim.